Hello, good day! Ito nga pala ang inyong Sir Jello at mayroon ako ulit ituturo sa inyo na math video topics. Pero bago yan, huwag niyo munang kalimutang mag-subscribe sa aking YouTube channel na Sir Jello para maging updated kayo sa lahat ng videos na i-upload ko. Hello, good day! Welcome to another edition of our Sir Jello math video tutorials. For today, we're going to discuss about special right triangle theorems, which includes the 30-60-90 and the 45-45-90 right triangle. So let's start first with the 30-60-90 triangle theorem. So the side opposite the 30-degree angle is half as long as the hypotenuse, and the side opposite the 60-degree angle is square root of 3 as long as the side of the 30-degree angle. So let us first prove those sides that was mentioned in the 30-60-90 triangle theorem, which is the opposite of 30-degree angle is half as long as the hypotenuse, and the side opposite 60 is square root of 3 times as long as the side of the opposite of the 30-degree angle. Let us first prove that if you have this given triangle here, that this leg side BC is equal to 1/2 of AB, which is the hypotenuse. So we are given right triangle ABC with the measure of angle A, which is 30 degrees, and the measure of angle B, which is 60 degrees, and the measure of angle C, which is 90 degrees. So again, we're going to prove that this side BC is equal to 1/2 of AB. So by means of statements and reasons. So actually, we can prove that this leg is equal to 1/2 of the hypotenuse by stating the statements and reasons for each. So number 1, this is right triangle ABC with the measure of angle A, which is 30, the measure of angle B 60, and the measure of angle C, which is 90. So the reason is given. Now if we're going to discuss this one by one, it will end up with the last statement. So up to 21 statements that will prove that this segment or this leg is equal to 1/2 of the hypotenuse by the TPE, or this is the transitive property of equality. So that is the last statement there. And then the next one, for letter B, we're going to prove that AC is equal to square root of 3 BC. So if this is AC, we're going to prove that that is equal to square root of 3 times whatever the length of BC. That's why it is square root of 3 BC. Okay? So to prove that, we're going to apply the Pythagorean theorem. So the Pythagorean theorem states that a squared plus b squared is equal to c squared. So this is the Pythagorean theorem. Then we just plug in all the sides given, we have for A, we have 1/2 AB quantity squared plus AC quantity squared equals AB squared. Next you have, so we're going to square 1/2 AB becomes AB over 4 plus AC squared equals AB squared. And then you transpose AB over 4 to this side, or leaving us with 3 over 4 AB squared equals AC squared. And then we extract square roots for this one so that the squares will be eliminated. So you have square root of 3 over 2 AB equals AC, or that is the square root of 3 AB equals AC. It only shows that in the 30, 60, 90 triangle, if you are given, like in this figure, if this is your 30-degree angle and this is your 60-degree angle, it applies the law of the 30, 60, 90 degree, which is whatever the measure of this leg, which is opposite of 30 degrees, which is x, it will only be twice the measure for the hypotenuse, and the side opposite 60 degrees will be this length times square root of 3. So whatever the length of this side opposite 30 degrees, for this leg will be just multiplied by square root of 3 for the opposite of 60 degrees. So that is for the 30, 60, 90. Later on we're going to have our examples. Now for the 45, 45, 90 triangle theorem, the hypotenuse is square root of 2 times as long as either of the legs. So say that AC is equal to BC. So they share the same length. So we're going to, the given is triangle ABC, which is an isosceles right triangle, with AC equal to BC, that is represented by X. AB is represented by C, and the measure of angle C is 90 degrees. So we're going to prove that C is equal to the square root of 2x. So the first step or first statement is you just replace A and B by x, so x squared plus x squared equals c squared, then the Pythagorean theorem. Number 2, you have c squared equals, just add these two, 2x squared, so that is by addition. So therefore number 3 is c equals square root of 2x by extracting the square root of both sides. So this means that this is square root of 2x, or x times square root of 2. Here, let's have the examples. So find the measures of the missing sides in each of the following triangles. So here we have a 30, 60, 90 right triangle. So in this case, if you have a 30, 60, 90 right triangle, there's no need for you to use the Pythagorean theorem by just only looking at the position of the sides with their opposite angles. So in this case, for the first example, the opposite of 4 is 30 degrees. And we know that whatever the length of this side opposite 30 will be twice the product of C. So that becomes 8. So here the answer will be 8. And then for the opposite of 60, you just multiply the value of c by square root of 3 over 2. So why is it square root of 3 over 2? Since we know that the length of c is twice the product of this side. So c is 8, so that will be square root of 3 over 2 times 8. Just simplify, so that will be 4 square root of 3. Just cancel this 8 and 2, so that becomes 4. So the answer here is 4 square root of 3, which is accurate, since we know that the opposite of 60 is square root of 3 times the length of this side. So that is for the 30, 60, 90. Then for the 45, 45, 90, a right triangle, if you are given the legs like this one, you have 8 and 8, then the hypotenuse will be 8 square root of 2. You just add square root of 2 to the given legs. Now let us have this table using the 30, 60, 90 right triangle in order to solve for the other sides of this right triangle. So again, we know that the opposite of 30 will be x. Before, this will be twice the product. Then this is a b will be x times square root of 3. Okay. Let's take a look at the first given row. So the only given number here is c, which is 10. So if we're going to solve for a, that will be half of the hypotenuse. So this will be 5. And then b will be 5. You just multiply it by square root of 3. Okay. Next, for 11, so since we cannot, there is no exact division for 11, we're going to divide by 2. We can write here as 11 over 2, or by decimal, this 5.5. So our b will be 11 over 2 square root of 3, or can be 5.5 square root of 3. Next, third column, third row, you have 6 for a. So our b will be 6 square root of 3, and our c will be twice of a, so that will become 12. Next, for a, you have 15. So for b, you have 15 square root of 3. Then for c, twice of that, so that becomes 30. And then for b, which is 12, or we can write it as 12 square root of 3. So a will be 12, then c will be 24. So you will notice that we did not use the Pythagorean theorem anymore. It's just by looking at the position of the right triangles, we can actually solve for the legs or the hypotenuse for this triangle. Then next, we have the 45, 45, 90 right triangle. So you have here x and x, so this can be a, this can be b, or vice versa. So if the given is 15, c will be 15 square root of 2. For 12, you have 12 square root of 2. For 3/4, you have 3 over 4 square root of 2. C, since the given is 6 square root of 2, your A or B will be 6. We have 5 square root of 6, so that becomes 5 square root of 6 times square root of 2. or that's 5 square root of 12. You can factor this out, so you have 5, 4, and 3. So 5 times 2, square root of 3, or that is 10 square root of 3. And for our last number, square root of 3, this becomes square root of 3 multiplied by square root of 2. So that will be square root of 6. So the hypotenuse there will be square root of 6. So that is how we solve for the missing side, either the leg or one of the legs or the hypotenuse, both for the 45, 45, 90 and 30, 60, 90 right triangle. So that will be all for now. Thank you for watching and have a good day.